All right, so let's try example number 3. So in this example, we're going to determine the behavior of the function. And we're given a function that equals x cubed plus 9 times x squared minus 21x plus 22. The first part is asking us to find the derivative. Okay, we can do that. We can follow power rule along with the constant multiple rule. So f prime of x is equal to, by following power rule, bring down the power, that's a 3x squared, subtract 1 to the power, of course, bring down the power for this one, so that's 9 times 2, that's 18, times x, and then subtract 1 to the power, that's a 1, but we're not going to write it down, and then minus 21x, so we drop the x. And then the derivative of constant, we all know it's 0, so there you go. So we found the first derivative, now they're asking us to find the second derivative, so same process, right? We use the power rule along with the constant multiple rule. So bring down the power, multiply by 3, that gives you 6, times x, subtract 1 from the power of 2, that gives you 1. And then 18x, pretty much just drop the x variable there. And then the derivative of negative 21 constant term is 0, so we don't write it down. Alright, so that's what we have so far. Now we're gonna find the next part, which is asking us to find the next part of the problem. Use the closed interval notation to enter your answers. Determine the interval where the function is increasing or decreasing. So we know from the last section that we know how to find where the function is increasing, decreasing. We need to make a sign chart, right? So we'll begin by knowing we need to separate this interval, and we use the critical numbers to do that. So let's first find the critical numbers. And we know we find critical numbers whenever the first derivative is equal to 0, or when the first derivative is undefined. Because we already know that the first derivative is a polynomial, we won't have this case, right? So we're only working with the first one. So we're going to take the first derivative. We already have it up here. And we're going to set this equal to 0, right? So let's take a all right, so we got okay. All right, there you go. So we're gonna set this equal to 0 to satisfy this constraint and solve for x. All right, so let's go ahead and do that. Since we're gonna solve for x and this is a quadratic, we know that we have to factor this out first and factor all the way. So we know that because it's a trinomial, we're gonna factor it into a product of two binomials, where we're gonna have x minus 7 and x minus 1. And by the zero factor property, we know that we're gonna set this equal to 0 every factor, but we already know that 3 cannot equal 0, so that's a false statement. And this can just be solved by using simple algebra step. So let's see, we have, and then did I make a mistake here? That one's supposed to be a plus. That's supposed to be a plus, and so that's supposed to be a minus. So that's a minus. Okay, I can do better. Comma x equals 1. There you go. All right, so these are the critical numbers, and we're gonna use those critical numbers to create the number line. So let's go ahead and do that. Here's this perfect straight line. So negative 7 and 1. Remember, we have to put them in the right order. So we know that negative 7 is lower than 1. This is my x value, and we're testing the values of the derivative. We already know that the value of the derivative at x equals 7 is 0. The value of the derivative at x equals 1, at x equals 1, the derivative value is 0. What we're wondering is what the sign value is here, right? So for that, we're gonna test a few numbers. So negative 8, 0, and 2, right? I'm just choosing numbers that are easy for us to compute. And if it helps, maybe we should highlight where our critical numbers are, right? Just to make them more obvious, right? All right, so let's go ahead and test what is the sign value between those intervals, right? What is the sign value? Whether this is plus or minus, plus or minus, plus or minus. That's all we care, right? So let's not get too much, let's not get overwhelmed by this, right? So we're gonna take the derivative of this. We're gonna do it the most simple way as possible to make sure that we are not overdoing this problem. So we're gonna test these numbers. We're gonna test the other number. And we're gonna test the other number. All right, so what do we know from here? Well, we know that this is going to be 3 is a positive number. Minus 8 plus 7, that's going to be a negative number. Minus 8 minus 1, that's a negative number. And as we said before, when you're multiplying, you have an even number of, a product of even number of negative numbers, then the whole thing is going to be positive. This is going to be a positive. 3 is a positive. 0 plus 7 is a positive. 0 minus 1 is a negative. So here we have an odd number product of negative numbers. So this will be a negative number. 3 is a positive number. 2 plus 7 is a positive number. 2 minus 1 is a positive number. So we get a positive number as well. All right, so what we have here is positive, 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 negative, 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 positive, positive, positive. And so if we look at the function is increasing and then becomes horizontal, decreasing, horizontal, increasing, right? That's how we know, because when the derivative is positive, that means your slope is positive, that means you must be increasing. When your slope is negative, that means you must be decreasing, and so on and so on. So to answer the following question, which intervals is the function increasing or decreasing? And this case is increasing between negative infinity, right? Let's look at this, negative infinity to negative 8, and not negative 8, sorry. See, that's a good the reason why we should highlight it. So negative infinity to negative 7, and from 7 to positive infinity. See, I almost made a mistake. Negative infinity to negative 7, and then from 1 to positive infinity, right? So that's why it's important for us to highlight or make our critical number stand out. All right, so that's where it's increasing. Let's see where it's not, where it's decreasing. We can see that it's decreasing in between negative 7 and 1. So we have from negative 7 to 1, the function is decreasing. Right, so increasing, decreasing. All right, and there you go, right? So that was a good review from last time. So let's go ahead and move on to the next part, which is asking us to find where is the function concave up and concave down. So let's look at that. So for that, what we need to do is almost the same process as we did before, except that we're doing it for the second derivative. So we need to find where is the second derivative equal to 0. And so that's going to happen right? By looking at the second derivative, and we know that that was equal to 6x plus 18. So we're gonna set this equal to 0 to meet this constraint, and we're gonna use that to separate the number line, right? Like we did before on the first derivative. It's the same process, right? We find where this where this function is 0 and solve for x, right? Solve for x. So that means we're gonna take we could factor the 6 if we want to, right? 6 times x plus 3 equals 0. By the zero factor property, this implies that 6 equals 0 or x plus 3 equals 0, right? But we already know that this is never going to equal 0. So it's only going to be x plus 3. So subtract 3, x is equal to negative 3. So that is the number line we're going to be using, right? And maybe add a little more space here. There you go. 3, negative 3, x, f double prime. Remember, now we're at double prime. So what we're looking for is whether the double prime is positive or negative, okay? So like we did before, let's highlight this. That way we know that this is where the interval is being split up. So we're going to try the second derivative. And we just want to know what is the sign value. And I'm going to do it in the factor form because we still only want to know when this is going to be positive or negative, right? And we're choosing, we forgot to choose our numbers, but we're going to choose negative 4 and 0. I always try to pick 0 because it's always easy for us to calculate whenever we're dealing with some calculation. So that would be negative 4 plus 3 f double prime of 0. 6 times 0 plus 3. This will be plus times negative 4 plus 3. That's negative number. That's a negative number. Positive for 6 and 0 plus 3 is also positive. So that's a positive. So we have negative, 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 positive, positive, positive. So how does this translate to the function? Well, remember what it says, right? Negative means sad face. Positive means happy face, right? So this is how the function is behaving, right? In a general way, we can guess, right? So that means that is concave down and concave up on this side of the interval. So concave downward is from negative infinity, right? So if we look from negative infinity all the way to negative 3. And concave upward from negative 3 to positive infinity. And there you go. So we found where is the function concave up and concave down. Concave up, concave down, concave up. All right. And that's it for this example, right? So, all right. So I hope you guys found this helpful.